difficult to answer that question. So because of that weight plastic, we are going to remove this question 1.7. So the multiple choice will be out of 18 marks for now. And we can also go to question 5, Mr. Nambane. So question 1.7 is out. And then question 5, what happened in question 5? What happened? You must remember the question moves between the examiner, the moderator, and the quality assurer, and that. But for that, we managed to miss out. You see that 95. It was supposed to be 95 square centimeter, and then unfortunately, it was captured as a volume, whereas learners, they have to calculate using an area. So it is impossible to change the unit of the volume to the unit of the area. So this 95 centimeter cubed, which was supposed to be 95 centimeter cubed, was supposed to be used in question 5.2.1, where it says calculate the minimum force that was applied. So looking at that question 5.2.1, the minimum force that was applied, it will take about 4 marks. So the 4 marks also is going to be removed from the paper. But it doesn't mean that the paper will be out of 144. From the onset, some of the answers, we did not allocate them enough marks. So we removed question 1.7 and 5.2.1, but the 6 marks we managed to get it somewhere in the paper. So the paper will remain out of 150. So with that all said, the other questions in the multiple choice will accept them as they are quality assured. And then sorry colleagues for those costly mistakes. Probably learners were scratching their heads trying to figure out what is happening there, but it was just a matter of a mistakes that was allowed through the paper, but at least we were able to pick them up. So we can start with question 2, Mr. Nambane, on the memorandum. So I'll read from the question paper, and then we can discuss the memorandum. So question 2, block of mass 7 kilogram placed on a rough horizontal surface is pulled by 18.4 Newton force and accelerates at 2.1 meters per second squared to the left as shown below. So firstly, the first question, it says, define the frictional force. So here we can accept the part marking where the learner can say the force parallel to the surface that opposes the motion of object, that will be 1 mark for that part, and acts in the direction opposite to the motion of the object, that will be another mark. So that it's an easy 2 marks that learners can really get. So the second question, it says calculate the frictional force between 7 kilogram block and the surface. So it means the learner has to consider all the forces that are acting on the 7 kilogram block, which is the F net of the forces, the total forces acting. So the F net, it is made up of the applied force, which is given as 18.4 Newton, and then the F net is unknown, and then that object has a mass of 7 kilogram and it accelerates at 2.1. So what is going to happen for the equation, learner will get 1 mark. The substitution on the left-hand side with a frictional force unknown, it will be 1 mark. The substitution on the right, 7 multiplied by 2.1, it will be another 1 mark. So the final answer here the learner will get 3.7. So you must remember, we said other marks, we are going to distribute them across the paper. So the first mark of the 6 marks that is cancelled from question 1.7 and 5.2.1, it is on the answer. The magnitude, which is 3.7 Newton, it will get a mark. Please correct it on your memorandum. And then the direction also will get a mark. So it will be 5 marks instead of 4 marks. So we can move to another question. It says a 7 kilogram block still on the rough horizontal surface is now connected to a 3 kilogram block by a light string as shown below. So now they are using a 40.4 Newton horizontal force to pull the system to the left, and the system accelerates with acceleration A. So unlike in the top part where we knew the acceleration, now the acceleration is unknown for the next part of the question. So the frictional force of 11 Newton, 4.8 Newton act on the 7 kilogram and the 3 kilogram block respectively. So as drawn, you are able to see what is happening. It means you are going to have a tension between the blocks that is acting on the left-hand side, to the right. So 2.3, it says state Newton's second law of motion in words. So we know the first part of the Newton law does not necessarily have the mark, but what is important here is the net or resultant force must be mentioned at least once. So if the learner failed to mention the net force where it says the acceleration is directly proportional to the net force. If the learner fails to mention the net force there, they would have mentioned it up there when it started by saying when a net force, if the net force is there, then the learner can get that mark. And inversely proportional to the mass of the object, that is another mark. So it will be 2 marks, So the next question, it says, draw a labeled free body diagram for the 7 kilogram block. So you must remember 7 kilogram block is attached to the 3 kilogram block this time. So there is a tension that is acting in the direction of the 3 kilogram, and then there's a friction that is opposing the motion. There is an applied force, and you must remember that applied force is no longer 18.4 like in the first part of the question, but now it is 40.4 Newton, and there is a normal there and weight that are not doing work in this case. So draw the free body diagram. So for that free body diagram, each arrow with a label, it will be a 1 mark. So we are going to accept what is on this box. It means for W, we can accept Fg or gravitational force or weight. For the normal force, Fn, and normal force in words or normal, we can accept that. For the tension, we can accept the weight Ft and the weight tension. Fk, we can accept F, small f, the friction, kinetic frictional force, and F friction. And lastly, F applied, we can accept F only for capital F, and F applied, or we can accept 40 multiplied by 40.4 Newton, which is the force that is given this time. So that will be a clear 5 marks for question 2.4. So you must remember, like we said in the statement above, the acceleration is unknown. So that is why question 2.5 now it states, calculate the magnitude of the acceleration experienced by the system. So we are going to look as to how are you supposed to work on this one. But you must also remember, colleagues, we've got now 5 marks that we must distribute as we move to discussing this question paper. So let's look. We'll have the for 3 kilogram block. We can determine the F net there. F net is equals to FA, and then we can break it down by identifying the forces. So either of the two can get a 1 mark. So we are going to have T minus 8, which is equals to 3A, and then T minus 4.8, we award a mark there. And then for the 7 kilogram block, we also do the same for the 7 kilogram block. But for the 7 kilogram block, we are assisted by the free body diagram that we have drawn up there. So which is the F applied minus the frictional force minus the tension, which is both the frictional force and the tension, they are acting in the opposite direction to the F applied. So we are going to end up, for consistency, you must remember we gave T minus 4.8 a mark for the 3 kilogram block. So for the 7 kilogram block, everything there gets a mark. 40.4 minus 11 minus T, it will get a mark. So the next mark will be for both 7A and 3A, for both 7A, 3A for the 3 kilogram block and 7A for the 7 kilogram block. So that will be the 4 marks for the first part. Now, if the learner do the following, whether the learner is going to substitute anything or to add, you must remember we said add equation 1 and equation 2. Once you see that the learner is trying to add both equations, you must award a mark for that addition. Whether they add or they decide to substitute the other in terms of the other, as long as they attempt to do that before they get the actual answer, they will get a mark for that addition, which is an extra mark that was not there previously, and then it will be the mark for the acceleration. So instead of 5 marks, now it will be 6 marks. I hope we are still together. And that will be the end of question 2. But question 2, the total now for question 2, it is 20 instead of 18. I hope so far everything is clear in that Nambane. If there is any question, maybe we can address it right away. Okay. Thank you, Mr. Nambane. So question 3, it says a ball A of mass 4 kilogram moving east at a speed of 8 meters per second collides with ball B of mass 10 kilogram moving west. So it's a head-on collision. The kinetic energy of ball B before the collision is 61.25 joules. After collision, ball A moves west at a speed of 5 meters per second. Ignore any form of friction. So there's a diagram that really explain what is happening there, so that you don't forget when you are working on this. So the first one, it says question, define the term momentum. So this, I think this is a normal, easy definition. For now, we will say 2, or I've never seen it broken down anyway. So the momentum is a product of object's mass and its velocity. So it is 2 or 0 for this one. And then 3.2. 3.2 calculate the magnitude of A, the momentum of ball before collision, ball A before collision. So this is a simple calculation. They told you that the ball A is moving east and the mass of ball A is 4 kilogram and it's moving with the initial velocity of 8 kilogram. With the speed of 8 meters per second. So the simple equation P is equals to mv. Initially, we did not give the mark because we had a lot of marks to award to question 5.2.1 and the one in multiple choice. So now we decided to give the mark for the equation. That is why it is indicated with yellow. Those are the changes that we made. And then a simple calculation, the learner will get 32 kilogram meters per second. So each time it must be the magnitude and the unit there. And then that is all for 3.1. 3.2, it says, 3.2.2, momentum of ball B before collision. So you must remember, unlike ball A, ball B, now we are given the kinetic energy. Not necessarily the velocity like in ball A. So what we are going to do here, we are going to try to figure out what is the velocity at that kinetic energy. So the velocity, we just substitute the kinetic energy, and then that is half multiplied by 10, which is the mass of the ball, and then we are looking for V squared. So V is equals to 3,5. Thereafter, we are calculating momentum of B. Therefore, momentum is mv. That is a mark for that, and then 10 multiplied by the answer that we got from calculating kinetic energy, which is 3.5. And then we have the answer as 35 kilogram meters per second. So what is important here? We did not award a mark for the equation for kinetic energy, but we award a mark for the equation that leads to the answer, to the final answer, which is in this case, P is equals to mv. We awarded a mark there. We can look at it that way, because even the learner, when they can get 3.5 wrong there and substitute there 3.5 in the momentum equation, I don't think it is going to have much effect, because that substitution does not have necessarily a mark. So the learner will get a mark for the equation, but if 3.5 is incorrect, it means the learner will forfeit the other mark for the final answer. Because even if 3.5 was incorrect, it does not have any effect on the answer as such, because the answer must remain 35 kilogram meters per second. So that positive marking, it does not going to bear any effect on this question. So question 3.3, state the principle of conservation of linear momentum. So part marking again, the total linear momentum of an isolated system, that will be 1 mark. But please, let's not forget that all our definitions must be stated in correct context all the time. That is 1 mark, and then remain constant or is conserved in magnitude and direction, we can give that 1 mark. So the learner can say either remain constant or is conserved in magnitude and direction. That will be the 2 marks. So 3.4, calculate the velocity of the ball after collision. The velocity of ball B after collision. So these options, they are only based on direction. So let's say the learner in the first one, he takes the east as positive. meaning that the West will be negative. So the learner will get 1 mark for the equation of momentum, whether they broke it down or the original equation, and then 1 mark for substitution on the left-hand side, where 4 is multiplied by 8, and also where 10 is multiplied by a negative. There must be an indication that the second ball is moving in the opposite direction. And then after collision, ball A will be moving in the negative direction. And then we are looking for the final velocity. So the final velocity will be equals to 170. So what is the change there? The change, we initially had only 1 mark for both magnitude and direction. So because we want to be consistent with what we did in question number 2, we decided that we should give the magnitude also a mark there. So it will be 1 for the 170 meters per second, and then 1 mark for the east. So similarly, in option 2, it will be just a change in direction. The answer should be, it must be written as positive for that 1 mark, and then the direction must also be indicated. So 5 is the collision of ball A and B elastic or inelastic. So the learner for writing the answer as inelastic will get 1 mark for that. And then let's look into 3.6 by calculations. Support the answer in question 3.5 for 5 marks. So we know learners, they have to do this separately. The total kinetic energy before collision and the total kinetic energy after collision, but they have to do them separately because they cannot conclude just at the beginning. So in this case, they are going to have 1 mark for the equation. For both equation, they'll get 1 mark for both equation. In fact, for any of the equation, they'll get 1 mark. And then the whole substitution must be equals to 1 mark. And we are going to penalize the learner where the learner now look at the velocity in the direction of the west and then indicate that direction as negative. Sometimes you can find them this 3.5 putting a negative there. So we'll penalize 1 mark there, but we'll penalize once. If the learner does the same mistake here, we'll award a mark there. So it means the whole thing must be correct there for that 1 mark. And then the answer 89.25 and 64.45, both answers they get 1 mark. And then the conclusion where the learner says total kinetic energy before is greater than total kinetic energy after, it will be 1 mark, or the learner can use the magnitude, which is the sum, the answer they got from the top one, and then comparing it with the answer that they got from the second one, which is 189.25 joules greater than that, they will get that mark. So it will be a 5 marks. So remember, initially it was 20 marks, the total for this question, but now it's going to be 22 marks because I said when we started, we want to maintain the paper at 150, though we substituted, we removed actually some questions. Any question in question number 3, Mr. Nambane?
Okay, I was just going to ask on question 3.6, the conclusion thereof. If a learner says total kinetic energy before is not equals to the total kinetic energy after, because I see it's not in the option. Yes.
Yes, I think we are going to accept that. It was it Ntate Ramabodu? Thank you, Ntate Ramabodu. At least somebody said something. It's like I'm sitting here alone talking by myself and I don't get any feedback. So at least when I get somebody responding or asking, then that's a good sign.
No, we're listening.
Okay. All right. Okay. I think we should not give that a number. I think we should just, our learners, they have to know that we are not talking only about kinetic energy, but we are referring to the total kinetic energy. Yes. Yes. Total kinetic energy. Thank. Oh, is it from 3.22? So let's go to 3.22, Mr. Nambane. What do we need in 3.22? Yes. Okay. So for the new markers, if the learner calculated kinetic energy and got it wrong here, let's say the learner get 4 meters per second, and then the learner goes to the question that we are working in 3.6. So you see in 3.6, we've got a 3.5 there. So let's say that learner substitute the answer that he got from 3.22, which is 4, for the example that I gave. So we are going to award the mark here because the learner is working. The learner maintains that the answer for kinetic energy, it is that wrong answer that they got from 3.32. So it means here we are going to mark everything as correct. We are going to recalculate what the learner did using that wrong answer and then give the marks. I'm sure, Mr. Nambane, I managed to cover that one. Similarly to what is happening in 3.4, can you go to 3.4, Mr. Nambane? You must remember the answer to 3.4, it is 1.70. The velocity there is 1.70, 1.07. And then the learner take that wrong answer. Let's say the learner got 2 here, for argument's sake. And then we go to question 3.6, Mr. Nambane. So where we see 1.7, which is somewhere there, and the learner maintains that the answer that they use in 3.4, which is a wrong answer, which is 2 instead of 1.7, they substitute that 2 there. We are going to recalculate the work of the learner and then award all the marks. And Nambane. Yes. We are going to question 4 now. So question 4 says, a brick of mass 1.8 kilogram is dropped from the height above the ground as shown below. So if it is dropped, this means the velocity of the bricks of that brick before it is dropped is equals to 0. So the brick hits the ground with a speed of 5.2 meters per second. Ignore all form of frictions. So number 4.1, define mechanical energy. So this, it will be a 2 or 0, Mr. Nambane, please, you can indicate there. So the sum of the gravitational potential energy and the kinetic energy, that will be 2 marks. So for this one, we are going to be a little bit strict. It is a 2 or a 0. So question number 4.2, what is the kinetic energy of the brick before it was dropped? So like I mentioned, at that height, before the brick was dropped, the velocity is equals to 0. So since the velocity is 0, it means the kinetic energy before it is dropped is equals to 0 as well, since velocity is 0. And then question 4.3, calculate the kinetic energy when the brick hits the ground. So can we calculate that? Yes, we can calculate it, because now the brick, it was mentioned in the question that it hits the ground with a speed of 5.2 meters per second. So we've got the velocity now, unlike when it was at the top of that height. So whereby EK, we'll give 1 mark for the equation, and then we give 1 mark for the substitution. Everything must be correct there. And then which is half multiplied by the mass multiplied by the velocity, the velocity with which it hits the ground, which is 5.2, and then EK is equals to 24.34 joules. So that will be a clear 3 marks there. And then number 2, it says number 2, calculate the height from which the bricks that brick was dropped. So we want the height. So it means we are going to use mechanical energy there. That is why I think 4.1 was leading us when it says you must define the term mechanical energy. So now we are going to use mechanical energy, which is mechanical energy at the top of that height is equal to mechanical energy at the bottom of as that brick hits the ground. So what is going to happen? We are going to have 1 mark for the equation, whether the learner broke it down or wrote it as the first equation like it is indicated there. It will be 1 mark. So let me explain something here. 1.8 multiplied by 9.8 times the height. We are going to award that part. You see it is in yellow. This means this is an additional mark. And then the second mark of the substitution, we are going to award it either on the first 0, whereby kinetic energy is equals to 0. Kinetic energy at the top is 0, because we can award a mark either there or either where mechanical, the potential energy is equals to 0. So this 1 mark can either be on half 4 multiplied by 0, or can be on 4 multiplied by 9.8 times 0. So one of the zeros must be there for that learner to get that mark. So if by chance your learners are not used to writing the 0 and all that, it means they are going to forfeit 1 mark in this problem. They have to show those zeros all the time. And then the last mark for substitution will be on 24.34, of which this mark let's say it will be for the whole size there, because the 24.34, it was awarded a mark there. It was awarded a mark in 4.3.1. So the whole side here must be positive. So that 0 has to be visible in that side. So, but we can compromise for now by saying, okay, we can give any side a 0, and then that 24.34, that will be a bonus, and then the answer will be 1.38 meter. So, which is 5 marks instead of 4 marks in the question paper and the previous memoranda. And then 4.4. 4.4. It says the same brick slides down the frictionless ramp as shown until point A. Between point A and point B, the brick experiences the friction force of 8 Newton until it stops at point B. I know a lot of people will do a lot of analyzing here, that when the brick stops at point B, the velocity, final velocity is equals to 0, and all the rough surface is going to have the effect on that brick until the brick it stops. So somebody can be thinking about the final velocity, but look at the question. The question is not interested in that. The question says calculate the net work done on the brick between point A and B. So it means learners between point A and B, they must identify the F net, the number of forces that are acting there. If there are more than one, they must add them together to get the resultant force. But in this case, since there is only one force acting in the opposite direction, it means that force is equals to the net force. So that is why we are using equation work net is equals to F net delta X and then the cos of the theta. So we don't have to worry about the frictional force being negative. The cos of the theta will be responsible for that negative. That is why we are having 8 multiplied by 2, and then the cos of the theta, it must be there for the learner to get that 1 mark, and then the negative work is done by the frictional force, or which is the magnitude of that force is 16 joules in the opposite direction. So that will be 3 marks. Mr. Nambane, I think question 4, that is all about it. Four, 3, 1, yeah. Mm. No, I think we should include the positive marking, because this is an extra mark actually in Nambane. We were not supposed to award that mark actually, because the learner calculated that it was awarded in 4.3.1. So just for the benefit of the learners, we can include the positive marking so that all the learners, they get that 1 mark. Yeah, that is a serious donation. So yes, I think that is us being generous in this case. And then if we don't do a positive marking, we will be unfair to other learners. Yes. Yes. Mm. And I need to emphasize that the Nambane, the mark for the zero, if the zero is not there, colleagues, they should not just put a mark with a zero with the red pen and put a mark. If the zero is not there, we are going to penalize that one mark. Yes. Question 5, you must remember the top of question 5, that is where we had a problem. You see on this memo that the number 5.2.1 is cancelled, but not 5.2.2. So 5.2.2 remains. Ne? Thank you, sir. Thank you, sir. So let's check. The stress of the steel rod that is 3 meters long is 2.77 multiplied by 10 to the power 8 Pascal. The cross-sectional area of the steel, then you know the story by now, is 95. It was not supposed to be 95 square centimeter. And the steel roll stretches to 0.22 when force F is applied on the rod. So what is going to happen? We are going to answer 5.1 and part of 5.2, and then lastly 5.3. So 5.1 is they define the following: restoring force. That number. I will need your input here. Please. There were some definitions that I'm not sure how do you mark it during the final marking sessions, especially whether you have part marking or that. You'll guide me when it comes to such things, né? Because I may not be sure how do you actually do the marking when it comes to those definitions. So the first one, I think it will be justified for this one to be 2 or 0. A force that is equal and opposite to the deforming force applied to a body. I'm not sure, Mr. Nambane, is it 2 or 0 normally? Okay, restoring force. No, I think it's okay. 1 mark. Okay. Okay. No, I'll accept a boost. Yes, no, I accept that. That is why I mentioned that, né? Because I'm open to such things, where learners they really can get something. Let's ensure that they get something. Yes. So 5.1.2, perfectly elastic body. You must remember this spoiled question 1.7, né? So a body, so this one is 2 or 0 on that basis, that number. It spoiled question 1.7, so we are not merciful on this one. A body which regains its original shape and size completely when the deforming force is removed. That was on a lighter note. I'm not sure how do you mark it. You can guide me there. It's 2 or 0. Okay. No, thank you. So 5.21, it is out for the reasons that I mentioned earlier. Maybe people who joined And later we can explain that again to say 95, it was given in square, in cubic centimeter, which suggests that it was a volume. And then we wanted an area. So learners were not able, or they won't be able to change the unit of a volume to the unit of an area that is required in calculating 5.21. So for that reason, that is why we are scratching off 5.21, because that 9.5, it must be the area, not the volume. But 5.2, the strain on the steel, so it is a little bit independent from 5.21. So that is why we are saying this one will stand. It will be 1 mark for the equation, and then 1 mark for the numerator, and then denominator 1 mark, and then the answer will be 1 mark as well. So 5.22, we are marking it definitely. And then 5.3, state Hooke's law in words for 2 marks. So within the limit of elasticity, stress is directly proportional to the strain. So that is part marking for 2 marks. I hope we don't have issues in this paper, in this question, because this question, I think that 95.95 cubic centimeter and that number, and each time I look at it, I get angry actually. Nambane, we are done with this one.
No, I was unmuted by mistake in that, sorry.
Okay. While we are waiting for the Sedin and the day Nambane, can I check with the colleagues, any one of them, are you sure what to do exactly in question 5? Those that we cancel and those that we mark, are we clear on that one?
Yes, thank you.
Clear to me, sir.
Okay.
It's clear, Mr. Nambane.
Question 6, the picture below indicates the relationship between the viscosity of a car oils and the temperature. So what is important about this question? The learner, they have to understand, interpret those numbers, the number that comes before the W and the number that comes after the W. So the number before the W is the viscosity of a substance at a lower temperature. And then that comes after W is the viscosity at a high temperature. So question 6.1, define viscosity. So this one I think is part marking. The property of the fluid to oppose relative motion between the two adjacent layers. I think that one is quite straight. And then draw a graph to illustrate the relationship between the viscosity and the temperature. So as the temperature increases, the viscosity is lowered. So I think the graph is clear that the relationship, it is like this. When temperature increases, viscosity is lowered. And then that will be the 3 marks you mark according to that guideline. The x-axis labeled, that will be 1 mark. The temperature labeled, that is another mark, and then the correct shape. Don't compromise the shape there. And then 6.3. Which oil has the lowest viscosity when it is cold? So like I said, the number that is on the left of the W indicates the lower temperature. Lower temperature means cold. So which oil has the lowest viscosity when it's cold? So the answer to that, it will be 0. So you can accept only, you can accept 0 there. And then choose from A to E. I think 6.3, we will say the answer is E. And then 6.4, which number in the viscosity did you use to answer your question in 6.3? So it is number 0W, or you can say the number that precedes the W. It means you looked at the number that comes before the W to make a decision, and then you decided that 0 is the lowest. And then 6.5, a bag that must be compressed with a force of 500 Newton is placed on a bigger piston. So the maximum force F1 of 60 Newton is applied on a small piston with an area. So the area of the small piston is 4.5 cubic centimeters as shown. So define the pressure at a particular point. So the pressure at a particular point, I think this will be 2 or 0. That number. How about this one? Is 2 or 0. The thrust acting on the unit area around the point. So that will be a 2 or 0 question. And 6.6, calculate the area A2 where the bag must be placed. So the area A2, it goes with the force of 500 Newton. So the equation will be 1 mark there. And then the force of 60 is applied, is on the area of 4.5, and then the 500 is on a certain area that we are looking for. So 2 marks for substitution. And then the force, is it the force? Is the area, ne? So there's a mistake there. The number 6.6, that must be area, not the force. So the area is equals to 37.5 square meter, which is 4 marks. So the calculation is just as simple as that. Any question in question 6? Any question in question 6, colleagues? So from question 7, now we are looking into organic chemistry. So a letter A to F below represents 6 organic chemistry, which is A to F like that. Use the information in the table to answer the question that follows. So you'll see that those molecules, they have different functional groups. They are in different functional groups, and then you have to identify them and then answer the questions as they follow. Write down the letters that represent the following. For example, number 1, a haloalkane. So when you are looking at A and B, they are haloalkanes. There's those branches. There's an attachment of a halogen in both of them. So in A, I think the third carbon, according to that from the right or from the left, there is a chlorine there, which is a halogen. And then in B, 2,3, it says 2,3 dibromo, which is a halogen. So it means haloalkanes will be A and B. So 7.1.2, an ester. So an ester in this case will be our C. So we know by looking at C, one of the oxygen will be double bonded on top of one carbon there, and then we'll have another oxygen that separate the oiled part and the alkyl part. So what is going to happen there? It seems like C, it is the only ester in this case. And then number 7.1.3, a ketone. A ketone is an E in this case, and then I know all of us, we know how to identify a ketone. 7.14, an aldehyde, butanal. So you can tell from the name ending that is an aldehyde. So 7.2, write down the IUPAC names of the following compounds. Compound A. So compound A, in carbon number 3, we are having a chloro, but our numbering will start from the right-hand side because we have a methyl in carbon number 2 from the right-hand side. So when we number from the right to the left, it means it will be carbon number 1, carbon number 2, there's a methyl, carbon number 3, there is a chloro. So alphabetically, the chloro comes before the methyl. So it will be 3 chloro and then 2 methyl, and then the longest chain in this case will be a pentane. So how do we mark this? Looking at the marking criteria, the stem, the pentane gets 1 mark. So all substituents are there, the chloro and the methyl are there, they get another mark. And then the IUPAC name completely correct, including numbering, sequencing, hyphens, and comma. So it will be 1 mark. So firstly, the longest chain. Secondly, the chloro and the methyl, they get 1 mark. Nambane, are you there? Yes. So is it my this one? I'm asking because you used to mark a lot of chemistry many years now, ne? So bullet number 2. It means we are not considering the order in bullet number 2. As long as the methyl is there and the chloro is there, we give 1 mark. Am I? Oh, okay. So if that are there, okay, yes. So you penalize, yes. Okay. Yes, I think that is clear. That is clear. The chloro must be there and the methyl for the second mark. And then we can move Ntate Nambane to question 7.2.2. Write down the IUPAC name for the following compound. I think E, compound E. So the name of compound E, 2,2, it is butanan or butan 2-nan, that is 2 marks. And then number C, it will be that ester that we were referring to, which is ethyl propanoid. So ethyl 1 mark, propanoid, it is also 1 mark. So 7.3, write down the structural formula of compound F. So compound F, it has 4 carbons. And then this is how you mark. The correct functional group is there. 1 mark, the whole structure is correct, another 1 mark. So I think that one is quite clear. 7.4, is compound D a primary, secondary, or tertiary alcohol? The compound D is an alcohol. Is it a primary, secondary, or tertiary? And then explain the answer. It is a tertiary alcohol. Why? Because the carbon atom bonded to the functional group OH is bonded to 3 other carbons. So I think that will be part marking for the second part of the answer. And I'm tempted to say that number we can look into the negative marking. I'm not sure if you still apply the negative marking. As the numbers. Okay, we must leave it like this. Okay. All right. So that is question 7, and I think question 7 is straightforward, which is 17 marks. Question 18, or can we allow some questions maybe? But yes. Yeah, question 8, I think it's on physical properties. 8.1, 5 compounds A to E are used to investigate vectors affecting the boiling point. The result obtained are shown in table below. And then that is the table of the compounds with their different functional groups and their boiling points on the right. So define the term boiling point. So we will award 2 marks if the learner says the temperature at which the vapor pressure equals the atmospheric or the external pressure. So that will be 2 or 0 as indicated. And then question 8.2, in one investigation, the boiling points between A, B, C are compared. A, B, C. So it means when we focus only on A, B, and C, we are concentrating on compound that falls under the same homologous series. So they are all of them, they are the alkane. So we'll be interested in the chain length or something like that. So question, write down the homologous series to which this compound belongs, 8.2.1. So they are all of them, A up to C, they are alkanes. And then number 8.22, write down the independent variable of this investigation. So it will be either number of carbons, the surface area, or the chain length. It will be 1 mark for that. So 8.2.3, explain fully explain the trend in boiling point from compound A to C. So like I said, the chain length is the area of interest in this case. So this is how we are going to answer this. We are going to look into the structure, the intermolecular force, and the energy. So firstly, from A to C, there is an increase in the chain length. So the number of carbons or the molecular size, or if the learner says the surface area is increasing from A to C, then we are going to award that 1 mark. So when it comes to the intermolecular force, we are still looking from A to C. It means stronger, or there is an increase in intermolecular force, stronger or more intermolecular forces, or van der Waals forces, or the London forces, induced dipole forces, dispersion. They from A to C, they are getting stronger. So it means C will have the strongest compared to A and B. So lastly, we are looking into energy. More energy is needed to overcome those intermolecular forces as you move from A to C. So more energy will be needed in the molecule C to break the intermolecular force. I think this one is quite straight. So then we are going to question 8.3. Question 8.3. Can I continue? 8.3, consider compounds C, D, and E. Write down the letters of the compound with, firstly, the lowest vapor pressure. Give a reason for the answer. So when you're looking C, D, and E, we know that the one with the highest boiling point will have the lowest vapor pressure. So it means 8.3.1, it says lowest vapor pressure, and then it means it will be, where am I? It will be E, which is butane 1-ol. And then the reason for that is because butane 1-ol, it has the highest boiling point of the 3. You must remember the 3 we are talking about, it is C, D, and E. So when you compare C to E, the E will have the lowest vapor pressure. So 8.3.2, weakest intermolecular forces. So the one with the weakest intermolecular forces, it will be the one with the lowest boiling point of the 3. So in this case, comparing C, D, and E, then C will be the answer, which is pentane. It can be C or pentane, we accept that. So 8.4, in another investigation, the boiling points of D and E, so we are looking only at D and E, are compared. Fully explained the difference in the boiling points by referring to the type of intermolecular forces present in each of the compounds. So we are comparing D and E. So let's look at our answer. Between molecule D, butanol, which is part of the aldehydes, are dipole forces. The learner get 1 mark for that, because we are comparing. So we have to know what is happening in D and also what is happening in E. So between molecules of E, then butanol, which is alcohol, they are hydrogen. So already you have identified already. It means your comparison is between the hydrogen bonds and the dipole forces. So on bullet number 2, intermolecular forces between D molecules are weaker than between E. That is the 3rd mark. So you must remember this is 4 marks. So the 3rd mark, you are comparing the intermolecular forces between D and E by saying intermolecular forces between D molecules are weaker than that, or you can write it as the opposite one. Intermolecular forces between E are stronger than the D, but I think there is an option down there. And then bullet number 3 for the fourth mark, less energy is needed to overcome or to break intermolecular forces between the molecules. Obviously, it will be compared to E. So that will be the fourth mark. And that the number, if you can go a little bit down, we can look into option 2 there. Option 2, it says the dipole forces between D molecules, butanol aldehydes, are weaker, that is 1 mark, than the hydrogen bonds. So you are stating the intermolecular forces already between DN and D. That will be than hydrogen bonds between E molecules. Then butanol, which is alcohol. So obviously you have 3 marks is given there. And then the second bullet, less energy is needed to overcome or to break intermolecular forces between the molecules, or the learner can say more energy is needed to overcome the intermolecular forces between the E molecule. So that will be our 4 marks. And then 8.5. 8.5, Mr. Nambane. In electronic device, doping is an important part for consideration. Semiconductors are also used widely in most devices. Define the following. 8.5.1, define doping. So we are going to define, this is part marking, the process of adding impurities to intrinsic semiconductors. That will be the second mark. 1 mark for the first part, and then the 1 mark for the second part. So in the second one, define the semiconductors, a material that has electrical conductivity. That is 1 mark between that of a conductor and the insulator. That is the second mark. And then 8.6, write down the names of 2 types of semiconductor. It is N-type and the P-type. That will be 1 mark each for question number 8. So question number 8, it is 20 marks. That number.
Mr. Nambane and Ndate Siapamore, I just want to check with you regarding question 8.2.3, because of what I have realized in terms of the question interpretation, because some of the learners, they just compared compound C and compound A with respect to chain length, strength of intermolecular force, and energy requirement. Because what the learner wrote here is that compound C is having a longer chain length than A. The intermolecular forces in compound E are stronger than that one of compound A, which results in energy requirement in C is more than in A, Minier. So they did not just write it from A to C. Yeah. Thank you, Minier.
Ndade the number, I would say we can accept it for now. Ne? Let me qualify why am I saying that. Look at question 8.4. Ne? In 8.4, it says, in another investigation, the boiling points of compound D and compound E are compared, of which this is what the learner was doing in question 8.2.3. He compared only what is that question? A and C, ne? Is it 8.3.2? Yes, then the learner compared A and C. So I'm saying we accept it for now, but teachers must go back and then explain the difference between these two questions. Yes, so I think there's a vast difference between question 8.2.3 and then question 8.4. So that must be explained. Thank you, Ntate Nambane.
Clear. That the number will correct that, Minier.
Okay.
All right. No, thank you.
Okay. I've been talking alone in this room. At least I'm getting closer. Question 9. If you look, first thing that you see on this page, there is a yellow tick there, the yellow covered, the tick covered with yellow. It means it is one of those questions, an additional mark that we awarded. So 9.1, the question 9 says, consider the diagram below showing a ray of light traveling from water from more dense to air, which is less dense. So define the term refraction. So here, I think with your lead, Nambane, you can assist us again here. The bending of light when light passes from one medium to another medium. So do you normally give 2 or 0 on that number? 2 or 0, and 9.1, 2 or 0. And then 9.2, in the diagram above, the light bent towards or away from the normal. Explain your answer. So they want to know if the light is from the dense medium to the light medium. Is it moving towards, is it bending towards the normal or away from the normal? So 9.2, it will be away, but the learners, they had to explain their answer because the light ray moves from a more dense to a less dense medium. That will be an extra 2 marks, which makes it to be about 3 marks. So therefore, 9.3, redraw the above diagram in your answer book and show the direction of the light when moving through air. Label the refracted ray and the angle of refraction. So the learner will draw and then they will show their work. So firstly, the additional mark, let me start with the additional mark. I understand somebody can say, but we have given some mark in 9.2. So that is why I'm calling it an additional mark. So and learner can know a definition or support the definition in a certain way. But when the learner draw, now they can draw something different. So we are going to look closely into what is going to the direction of the refracted ray. So if it is bending away from the normal, like in the memorandum, there will be that extra mark that is given on top of the marks that were supposed to be awarded for the angle of refraction and the refracted ray. It means this one, instead it will be 3 marks. So we have added an extra mark there because it does not necessarily mean when learners they are able to explain it up there, then they can easily draw it. We are giving it as an extra mark. And then 9.4, state one condition that leads to a total reflection that has reference to the angle of incidence. It means we strictly want the learner to state basing their argument on the angle of incidence. So it means if the learner says the angle of incidence must be greater than the critical angle, that is 2 marks, we accept only this because the question there, it stated clearly, it says that has reference to an angle of incidence. So it is 2 or 0, but the learner must state only this. An angle of incidence must be greater than the critical angle. So it's very important the learner must state with reference to the angle of incidence. So 9.5, light can undergo a phenomenon whereby it breaks up into a component color. So 9.5.1, write down the name of the above phenomena, which is the dispersion of light. That will be 1 mark. And then which color is most refracted? That is the violet color. It will be another mark. Explain why the color mentioned in 9.5.2 is mostly reflected. So it has the highest frequency. I'm sure we can add something there. If anybody can think of something, maybe we can add it because it has the highest frequency. That is why it is refracted the most. So, and then 9.5.4, what is the relationship between the speed of light and the wavelength when light passes through the medium of different optical bands? So in this case, it will be 2. When the speed of light decreases, the wavelength of light also decreases, or vice versa. But I like it in Afrikaans, wanneer die spoed van lig verminder die golflengte en omgekehrt. Yeah, so that is the final answer, which is 2 marks. And then that will be 14 marks. You must remember, we have added another mark here in that number. I think it will be 2 for 10. Oh yeah, would you mean another number? Is it supposed to be again? How many marks do we have? Yeah, I think it's 15 marks now. Instead of 14, it is 15 marks. Yeah. So in that number, that would be about all. Yes. The violet color. Yes. Yes, that is why when I was reading it, yes, that is why when I was reading it, I realized we could have added another thing there in terms of the wavelength. Yeah, shorter. Yes. So that is that or that. So colleagues, let me say this. I'm sure the colleagues in that day, Nambane, they have begun to set their own tasks or participate in the paper setting. And once they do that, they will realize such things they do happen. The mistakes like that happen in this paper. I'm not justifying anybody, but they do happen. And then, but we want to take the blame for not picking those mistakes. But I think we have made up with those addition of some extra marks so that our paper should remain out of 150. And then thank you for being organized, colleagues, and we had a beautiful meeting. Thank you, Daniela. Yes, can you go back a little bit higher? Away. Yes, yeah, I think negative marking should apply here. And that, yes, yes. Five 5.2.2. Or the meter to centimeter. Okay. Yes, no, we can accept that. Yeah, we can accept that. Mr. Nambane, I think this part of 5.22, are we going to have an addendum? Or do you want to write it here so that they capture it already, whereby the learner is converting the units to centimeters, all the units to centimeters? Okay. 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 Yes.
Colleagues, good day. Thank you very much for your attendance and thank you very much for the questions, colleagues. It shows that everything is done for the benefit of the learner. I was tempted to say something when you're talking about that organic chemistry, that physical properties questions, but let me just keep it as it is, as the decision was taken. But colleagues, let us ensure when you go back to the learners that we explain to them the meaning of the words, because sometimes the English is not really easy to interpret for the learners. So when the question says, for example, the trend from certain compound to certain compound, it means all the compounds actually are taken into consideration. So let us go back and explain those. But thank you very much, colleagues, for the attendance, and thank you very much for your participation. And if there's anything that you find as you are marking, feel free to post it in the group, or straight to Mr. Nambane or myself or Ndati Sipamore, and then we'll take a decision. And all the best for everything, colleagues. I hope your learners will pass. We made those distinctions again. So all the best for everything, and have a good day.
Bye.